it's asking you for the formula here. What is the formula? Well, it's A of t is equal to A sub 0, the initial amount, e to the negative kt, because it's a decay function, so there's a negative here, negative kt, right?
Because it's pretty much the same formula, right, Shauna? Like
The
it
only,
to
the
me
only
looks that
difference,
negative, right?
right, the only difference in the decay function is that this has a negative in front of it, so it's actually decreasing instead of increasing. Okay.
I see.
And then it says right in it, it is found that 8 pounds of A will reduce to 4 pounds in 4.5 hours. After how long will there only be 1 pound left? So in this case, this is a two-step scenario, and we worked on some of these the other day.
LN, yes, I see that you did the LN.
So yeah, so it's very similar. You have to find K, and then you have to solve for what they actually ask you. Look here, let me share screen again. So here we have our, so I tried to set it up so that you would understand.
Yes.
What, and so 4, which is the amount that's reduced, so that's my 8, and then I solve for K first. And then what I have to do is, it doesn't want me to round, so I used this exact expression, and then I want to solve for T, so I want to put this in there. Now 1/8, if you reduce this as a decimal, 1/8 is 0.125. So I just plugged in everything. And I get 13.5, and it asked me for the nearest year, the nearest hour. So that was 14 hours.
Nice.
Okay. The next question was very similar. It said the half-life T for a particular element. Oh, it didn't.
Find the decay rate of the element.
It didn't, it didn't copy the rest of it. I don't know why.
That's okay. When I copy it to my homework, I'll go back to question number 2.
It says, here's the screen share. Here's what number 2 looks like. So it says the decay rate, the half-life T is 6 minutes. Find the decay rate, okay? So half-life means that what you have to understand about half-life here is that anytime you have half-life, that's the time that it takes for the original amount to reduce to half of itself. Okay, so we don't know how much we started with, but the thing is, we don't have to know that.
Yeah.
We just have to know that the ending amount was half of the original amount. So half of the original amount is the final amount, and that's equal to A sub 0, which is the original amount, which again, we don't have, but if you look here, this original amount is going to cancel because it's on both sides.
Yeah.
Right, and then you have E to the negative K, and your T you don't have, but your T is 6 minutes.
6 minutes, yes.
So this, you just
6K.
solve this for K, which we've done before.
Yes.
So you can go through, these are going to cancel, these A sub 0 is going to cancel. I just made 1/2 a decimal. And if you solve for K, you end up, now, the other thing that happens is you end up with a decimal here, and it asks for the percent. So don't be thrown off. by that?
Yeah.
Because that's the other thing that can wreak havoc in these problems. Is it comes out to 0.1155, which if I make it a percent is 11.6%. So not very hard.
And when you do the K and it's 0.1152, how do I convert it to percentage? Oh, times 100?
Multiply by 100.
Oh, okay, that's where you get 11.6. Okay, got it. I got it, Shauna. Yeah.
Yeah. And then the next one is very similar. The next one says the decay rate is, here they gave you K. All right.
So
they
you
gave
gotta
K,
find T.
and
Yeah.
it says where time is measured in years, find the half-life of the element. So here you're looking at, in this case, again, you have the same thing, but in this case, instead of this, you're gonna have this percentage is gonna be, now remember, here you have to divide 1.9 by 100. So you're gonna end up with and remember, it's gonna be negative 0.019 T. And again, so for T, the initial amounts don't matter. So for T, when you do that, you end up with 36.48, and that rounds to 36.5. So not that bad. Right?
No, I follow that. Yes.
These are pretty standard ones. Number 4, this was pretty straightforward too, but you need to do a little bit of calculations when you do that. So here you need to do your formula. As you can see, this one I think was probably the shortest problem on the whole, because it was just a straight substitution.
6,000, yeah, 6,000 E negative of 0.35 times.
We're looking for how much will remain. We're looking for A, and T is 140 years. Because it
T
says
is 100, okay.
No, 140.
140, okay.
T is 140 because T is your time.
So you multiply that with 0.035, right, Shauna?
Yeah.
Okay. Oh, okay. Gotcha.
And then it's just a matter of putting it into your.
Yes, very straightforward.
Now the next question is almost that way, but it's got one little nuance in there. Because it says they give you the formula. They give it to you this time. And your constant is a heck of a number, but it's right here. And then it says, how old is an ivory tusk that is lost? Now, this is the hard part. And it's not that hard. You just have to recognize it. It's lost 23%. Okay. So in this case, we don't know what the amount was. Okay. We don't know that. But what we do know, think in terms of percentages, kind of like you do for a half-life. So the initial amount is 100%. Okay? Or 1, right? So, or 1 times A sub 0, right? That's my initial amount. Now, my final amount, if I lost 23%, I lost 23%, okay? Well, I don't care how much I lost. I want to know how much I have left. So if I lost 23%, then that implies that I have one minus, or if you want 100% minus 23%. Okay, because I lost 23%. If you take 100 minus 23, you get 77%.
Got you. That was tricky. That was a little tricky, but not hard, huh, Shauna?
So A sub 0 here, this 77% of A sub 0 is your final. So you end up with, and I write it as a decimal when I write it. So I write 0.77 times A sub 0, because I don't know what A sub 0 was. Okay, but it's 77% of what I started with is what this says. Okay. And then I have, if you want, you can make this 1 A sub 0 to remind yourself that you started with 100% of it, right? Times E to the power. Now in this case, I used A's because I'm just used to using A's. They use P's. So you could change this as P sub 0 actually. And this is P sub 0. It doesn't really matter in practice if you're using P sub 0 or A sub 0, but it matters for the notation. So this becomes, and then you just plug it in. So there's your formula, right?
Yeah.
And then from there, notice that your P sub 0 is canceled because I have them on both sides.
Yeah.
Right? So when I divide here by P sub 0, this goes away. And then I have something that you're very familiar with.
Yeah.
Right?
Yeah.
The only tricky part, I'm just going to put etc. in the box. Right? So the only tricky part is right here. If you lost 23, you have 77. That's the only tricky part to that.
Got you. So that's
Okay.
2161 years. Okay, sure.
And if you work it out, then
Yeah.
again, the work is not that different from the work that we practiced. That's I worked it out, but I don't think the work itself on those should give you much problem.
Okay.
Now this one, this one caused Shauna a problem. So we're gonna explain this one. This one was a bit of a doozy going on here. So it's not as hard as it looks, but there is a manipulation in here that's a little hard. So the concentration of a drug in the body decreases exponentially after a dosage is given. So basically what this is telling us is the amount of the drug you have in your bloodstream follows an exponential decay is what that says, okay? In one clinical study, adult subjects averaged 15 micrograms per milliliter of the drug in their blood plasma an hour after 1,000 milligram dosage, okay? And 2 milligrams per milliliter 7 hours after dosage. Now, this is something that sometimes problems do this, okay? And it says find the value of K and write an equation for the function that can be used to predict the concentration of the drug in micrograms T hours after 1,000 milligram dosage. Okay, we're gonna deal with part A right now, okay? Now, what's different about this is how you work out the math a little bit, okay? The function is exactly the same, okay? So it follows an exponential model. So you have the concentration, I can call it C if I want, I can call it T, I can call it A, it doesn't really matter.
I see.
Concentration C of T, I'll call it C just because I think that makes a little more sense in this case. E to the negative. So I'm looking at this. This should look familiar. This is the same.
Yeah.
Okay, this is the same formula. Now, here's the problem. Okay, we don't know how much was initially in your bloodstream. We know what the size of the dosage was, right? But here's what we know. We know the concentration at 2 times. We know the concentration at T equals 1, and we know the concentration at T equals 7. Okay? We don't know the concentration. Normally, they give us the concentration at 0. That's what A sub 0 is. But we don't have that here. So we know that the concentration at T equals 1 is equal to C of 1 is equal to, what was it, 15 in this case, I think? Let me check. I gotta look because I don't remember. It said 15 micrograms after an hour and 2 after 7 hours. So here we have 15 micrograms after an hour. So we know what C of 1 is, that's 15. And we know that C of 7 hours is 2, right? So we're gonna plug it in, but here's the thing, okay? So we're gonna plug it in. Now, we're gonna have 2 equations when we do this, okay? And so let me find my notes. Give me a second. Okay, so here we have, we're gonna end up with 15 equals. Now here, I'm gonna drop the subscript and just call it C, all right? And I'm gonna have E. Now, this is T equals 1, okay? So I'm gonna have this. I'm gonna have C sub 0, but like I said, I'm just gonna call it C so you don't think the 0 is a number, okay? Then I'm gonna say that this is C e to the power of, now K I don't know, but T is 1, so this becomes negative K. All right, are you with me how I substituted?
Yes.
Okay, now I have another equation over here. I'm going to do the same thing with this other piece of information. So I'm going to say that 2 equals C e to the power of negative 7K. Negative 7. So then this becomes negative 7K, right? Now, the problem here is that I need to find out what K is. All right. So there's a couple of different, but K, bringing this down would involve logs and dividing, because I don't know what C is either. You see how I have 2 unknowns here? So actually there's a few different ways, and I debated with myself.
Oh, okay.
You can use logs. You can do a few things, and I'm going to use logs, but you can do a couple of different things with this. what I decided to do was that I'm gonna take the first equation and I'm gonna solve it for this e to the negative k term. So what I'm gonna do is I'm gonna divide by c. Okay.
Mm-hmm.
This is not the only way to do the algebra, but I think it's the cleanest.
Mm-hmm.
Now I'm gonna divide this by c over here.
Mm-hmm.
And what that's gonna allow me to do is minimize the use of logs until the end, like you're used to,
Mm-hmm.
and use the powers of exponents instead. So what I'm gonna end up with is I'm gonna end up with 15 over c is equal to e to the negative k, right? E to the power of negative k. And then I'm gonna say that 2 over c is equal to e to the power of negative 7k. Okay, is equal to e to the power of negative 7k. All right, so now what I'm going to do is I'm going to say, okay, well, I'm going to say that now I'm going to use logs over here, like you're used to.
Mm-hmm.
All right, so this is going to be
Log 15 over c.
I'm gonna have, right, ln 15 over c is equal to ln, and you know what happens when you do ln e to the power of negative k, you just get negative
k.
k, right?
Mm-hmm.
Now, I don't want negative k, I want positive k.
Mm-hmm.
All right, so what I'm gonna do here is I'm gonna do k. Well, I could plug in this will work fine because here, see this negative 7k, right? I'm gonna make a substitution over here, right?
Mm-hmm.
Because if negative k is ln of 15 over c, then it follows that if I multiply this by 7, so I get 7 times the natural log of 15 over c
Mm-hmm.
is equal to negative 7k, right? And the reason that I want that is so I can stick it here. So this is this, okay? And so I'm gonna stick this expression here into this. So I end up with this part. And so when I do the math for that, when I do the math, I end up with k is equal to ln of 15 divided by, now I have 15 and I have 2, right? And then I'm going to divide that by 4 because I'm sorry, not by 4, but by 6. So this is going to be, now I have a better have a better explanation of this. So what I'm gonna do is I'm gonna show you something here, because this is what I used. Let me show you what I used here. And I'll write it, because like I said, this is the one that I wanted to explain to you before I wrote it out, because I didn't just want to spring it on you and be like, oh yeah, like that's gonna make sense, because that I had to look it up 3 times to find it. So, but I want to show you, because there's a really good example that I used. Let me find my history. She did a really good job of explaining it. And she did something similar. I just need to find my history. Yes. Now I need to scroll down. I should have, if I had thought of it, I would have sent you this. So here, let me bring you up to speed. She set up the problem, and I'll send you the video link, but she set up she has a similar issue, okay? So it says the concentration of a drug in the body decreases exponentially. Here, they average 13 instead of 15, okay? And it was 4 micrograms after 5 hours. So she has her little chart, like I had my piece in my, right? And she set up so we have this. So we have P, just like I have the C's.
Yeah.
Okay. So you're here. She's using P sub 0. Now you have, she just moved this negative exponent to the bottom to make it positive. Okay. That's all she did. So you have a 15 and an e to the k and a 2 and an e to the 7k. All right. So what she's going to do now is these are both equal to P sub 0. You see? In our case, we have this. So we have, and she does the math, but she's going to set these expressions equal. So in your case, we have this. We have 15, so it's 15 over, and I should have divided by, I just realized this. I should have divided.
Hopefully we don't get that answer in the quiz or test, because it seems complicated a little bit, Shauna?
Well, the algebra is a little complex.
Yeah.
And you can see why I debated, because there are other ways to handle the algebra.
Yeah.
Okay.
Yes.
But I think this is the most
that was the hardest one in the section.
Well, no, I don't think, well, actually, I think the next one is harder, but I think the algebra here is just not apparent to you. Because like I said, there's different ways to handle
it. Yeah.
to handle the logs.
Yeah.
But you're not very good with logs. So I was trying to minimize how much you use logs.
Yes.
But you have to use some logs.
I see.
You see? So it just depends on how you set this up. But if you say, I think you can get here pretty easily. So 15 is equal to, you have 15 is equal to CE to the power of negative K, right? Then, excuse me, frog. So negative K.
You okay, Shauna?
And then you have, yeah, just, it's one of those situations where I swallowed my saliva and my frogs decided to come back for me. So this is going to be 2. 2 is equal to, this is going to be CE to the negative 7K. All right. So this is not so bad. I think you can handle this part.
Yes, I think so too.
Now from here, like I said, you can use logs, and she doesn't right now, but she will after this, which is kind of what I was trying to steer away from, but you can see why I wanted to make sure we went over it. So
I
this is
see.
going to be
I see.
negative 7K, right?
Yeah.
And so if you then say, before you take out the C's, this becomes, now, since this is a negative exponent, you get 15 is equal to, now this becomes a fraction. So you have 15 equal, this is going to be C, and we're going to divide it by e to the k, right? So you get 15 over e to the k power. Now, at that point, you have e to the 7k down here. And so what I ended up doing was I ended up dividing out the c's and then putting the e's together. So this is 15 here, and you divide by e to the k, so you get 15, and you're dividing by e to the negative k. So this piece of it, because you want the c to disappear, that's essentially what you want to have happen. So because here you have two equations in two variables, and that's the issue.
I see.
Get here, let me just advance this. When you get here, you're going to take p sub 0. See how they're both equal to p sub 0?
Yes.
You're going to set, in our case, that's c. You're going to set them both equal to each other. So 13 over e to the k is 4 over e to the 5k. All right. So in our case, that's going to be this. That's going to be, so you have, let me just do that. So we're going to set 15 over e to the k. This is going to be 15. We're going to divide it by e to the k. So this is e to the k power. And that's equal to c. Okay. And this one is 2 over e to the 7k. E to the 7k power. Now here, they're both equal to c, right? So if they're both equal to c, then I can set them equal to each other. And from there, I have to cross multiply and make the k's go away. Because I make the c's go away by equating them. So here I get 15. So I do, which this is not as hard as it looks. It's just the manipulation that you're not used to. 15 e to the k power should equal 2 equals 2 over, let me move it up. This is 2 over e to the 7k. And notice I haven't used logs yet. But I did use exponents, you see? So you can use logs if you prefer. And most of the explanations I saw did that. But now here, what you want to do now is you want to solve for k. All right.
I see.
So you have to get rid now of the fractions, right? So here what she does is she multiplies by the common denominator, which is e to the 7k.
Mhm.
All right. So if you multiply, and we've done this manipulation before. So if you multiply both sides of this equation by e to the 7k,
Mhm.
you have e to the 7k. And then you multiply by what's there,
Mhm.
okay?
Mhm.
And then you multiply on the other side by e to the 7k. Because what you do on one side, you have to do on the other, right?
True.
We learned that.
Yes.
If there's one thing that algebra, no matter how much algebra you remember or you've forgotten, people that don't remember that much algebra remember that. What I did on one side,
Absolutely. You
because
do it on the other one.
they just bury us
Yes.
with that. You know, that's one of
Mhm.
the mantras that you get buried with when you die an algebraic death. So this is 7k. Now what happens here is this drops out entirely,
Mhm.
right? And we just have a 2 over here. But now on this side, we get 15. This is 15. And this is where your exponents come in. So this is 15 over e to the k power, right?
Mhm.
So now you're multiplying by e to the 7k, right? Well, you have 15 e to the 7k over e to the k. And remember, when you divide, you subtract exponents, right?
Mhm.
So you end up here with 15 e to the power
Mhm.
of 6k
Mhm.
is equal to 2. Are you okay with that part?
Yes.
Now, at this point, we're solving for k. So now we want to use logs. At this point, we need to use logs. So this is going to be 6k times 50. Actually, I'm going to divide by 15. It'd be easier if I divide by 15 first. So if I divide by 15, I'm going to get e to the power
Mhm.
of
6K
6k
equals.
is equal to 2 over 15, right?
Mhm.
Now from here, you know how to solve this.
Yeah.
Because you bring this down, this is going to be
ln.
6k
Yeah.
times the natural log of e,
Mhm.
and we know what the natural log of e is
Mhm.
equal to the natural log of 2/15. And if you then divide by 6, so if you take k is going to equal the natural log of the fraction 2/15 divided by 6. Okay, and that's going to give you your value for k. Now that's the hardest part of the problem, is getting that. So once we get k,
Shauna, can I ask you again, when I do the ln, you told me that I have to use parentheses? Yeah, so I do the ln.
So
E.
you want me to do it? It's gonna be okay. So let me do it. So it's gonna be, let me get my calculator out. So we have, let me find my screen. Here it is. Smart View. Yeah, I'll do it so you can see how it comes out, and then we can match it with the homework number. Okay, so then this, let me get the screen share here. So you should fully, are you seeing it? You will in a second. There it is. Okay, so I'm gonna clear this out. So when I do it, I have ln, right? And I'm gonna have 2, right?
Mhm.
And then I'm gonna have 15. Oops. 15, close, right? And
Okay.
like that, because I want the natural log of the fraction. Like
Leave it
this.
like that. Don't turn it up. Leave it like that.
And then I'm gonna divide it by 6.
I see, Shauna. And that's 0.33. Okay, got it.
Okay, now that's my K. All right, that's actually, I think, the hardest part of doing it. Now it wants the function, so this is your K value,
Yes.
right? But remember, we didn't have C either, or P, or whatever they're using, right? So what we have to do now is we have to do one more thing. We have to go and we have to come back to, let me come back to this here. So if you look, there's your K right there, all right? That's the first thing it said. Then it said, write an equation for the exponential function. Well, I don't know what this constant is in front, do I? See, I didn't find the constant. I just found the K, right? So remember here that when I do this part, I have to come back here. And this is actually fairly easy now because we have C. C is this equation here.
True.
You see, use this because it has just the single K in there. You found K, all right? Found it. It's now use the full number of decimal places, okay? So this doesn't have any logs. It's just 15 divided by e to the power of K. So when you do this, it's this. It's 15. This is 15 divided by, and then you want to use a parenthesis here. Use your E key, which is on top of the natural log. So second natural log, and then I can just use the answer here. And then it's just the parenthesis from there, you see? And that gives me 20.9862. Okay, so what they're gonna do is they're gonna round this to 21 on your
Shauna,
screen.
give me 1 second because I need to look for my keys because my husband is gonna go somewhere, okay? Give me 1 second. Thank you.
Worries. Okay. So once we have this, then we can go back to the homework here. Okay, yes, continue. So notice that I have 21, right? There it is. There's my constant, my E, and my
negative, yeah.
right? Now, the only thing you have to do, part B is a straight substitution. So the concentration of the drug after 4 hours. So you're just gonna put a 4 where the T is. Okay, but you're gonna use this function that you defined in F. So you're gonna plug in 4 where T is. All right. So in this case, you're gonna say, it's gonna look like this. I'm gonna go ahead and come back to the calculator here. And I'm gonna plug in my numbers. So I'm looking for my concentration. So I'm gonna have 21. And then I'm gonna have E, so second E, right? And then I'm gonna just use the decimal here that they gave me, which I'm using negative 0.336, because that's the function that I define here. And I want the concentration after 4 hours, so I'm gonna put a 4 there. Okay. And if I do that, then I just end up with that.
Yeah.
5.476, whatever. Okay.
Mhm.
That's all I have to do for part B of the question. 5.5 grams. Now here, it's asking me, what is my T? So I'm solving for T, and we've done that before, when I know that my A is 3 micrograms. So what this looks like is it looks like this. I have the equation where, let's see, what do I want to do? I'm going to go to annotate, and I'm going to get myself a text box, and I guess I'll put it right here. Okay, so I'm going to have my 3 because I want it to be 3 micrograms. I start with 21. Then I go E, and I go to the power. So this is E to the power of negative 0.336. And I'm looking for the T. This time I don't know what it is, right? You know how to solve that. We've done it before. Divide by 21.
LN, yeah.
Take the natural log and then divide by this number. When you do that, you'll end up with about 6 hours.
I see.
Okay. So that's how that went. That was that question.
Wow. Yes.
Okay. That was mathematically, it's just solving for the K. That's hard. Not doing the, so you want to study the manipulation of that. But otherwise, it's not really all that different. Question 7 is
Question 7, I think I have it here in your notes.
it's pretty much the same.
Yeah.
Find the value of K. Here they give me 2 numbers, just like before, okay? But it's a little bit more straightforward. I had to do kind of a similar solving procedure, except they gave me, it says, the nice part about this one was, if you look at it, it says the population dropped from 52.8 million in 1995 to 44.5 million in 2007. Assume that P of T, the population, T years after 1995. Well, in this case, they gave you T sub 0. Okay, so your constant here is 52.8. So your equation should start, you don't have a fraction, so you can immediately get rid of B and C. And you know that your that your constant is 52.8, so it has to be this one. Now you have to solve for K, but you can do that. I did some problems that were similar, so that's not a hard thing to do. It's just the way they asked it. Now, number 8 is kind of a different bird, okay? Because you have to know there's a variation on the formula, and I had to look up the formula, okay? But I gave you notes on it.
Yes, you did.
Except I think the last step, I didn't do the division with the T, but I gave you notes on that. So I'm just gonna take a minute here. I'm gonna save this. Because and I'm gonna go ahead and go to my notes here and go to the bottom of them because I want to go over. It's not as hard as it's not as hard. It's just you actually have 3 constants you have to solve for instead of 2. Okay. A coroner arrives at a murder scene at 8 p.m. She finds the temperature of the body to be 86.9 degrees Fahrenheit. So that's your T0, right? Except now here's the thing, your T0, you don't have, because you don't know when the body was killed, all right? You just know that this is 8 o'clock, this happened.
Oh my goodness.
Right? She waits 1 hour and takes the temperature again and finds it to be 83.5. She notes that the room temperature is 63 degrees, assuming that the temperature of the body was 98.6 when the murder occurred. When was the murder committed? So now the trick here that might be a little bit tricky because of the way it's written is the T's, okay? This small t is, our reference point is 8 p.m. Okay, because that's when she got there. That's when they found the body at 8. Okay, she got there at 8. So our small t, our reference point, is when the body actually died, not 8 o'clock. Okay, we don't know when this was, but we do know that at the time the body was killed, this is 98.6. Okay. Now the constant C in this formula, that this is your freebie in this situation. Your constant C is whatever the room temperature is. Okay. So your constant C is 63 degrees. Okay. So now again, we have 2 equations here. And that's what makes this difficult. We have 2 equations, okay? So I did your little equation and I showed you the math. So 98.6, we don't know what this A is.
Yeah.
But we do know that at the time when the temperature was 98.6, that this was 0. So I did the math, and this comes out to 35.6. Okay. So we know what A is. We know what A is. We know what C is. Well, so now we know A and we know C. We need to know K. All right. Keep in mind, we want to know what T is. All right. But we can't see, we have 4 variables in this equation: A, C, K, and T. And I want T, but I have to analyze the situation to get A and C, and then I have to use what I've been using before to get K. Right? So I have, now here's what happens. I have 2 situations because she took the temperature at 2 different times, right? So I have 86.9. This is what happened at 1 hour, right? She took the temperature when she got there and it was 86.9 degrees. Okay. Now, we don't know what time that was, but that gives us this equation here. 23.9 is equal to 35.6 e to the negative kt, right? Now here's the trick. An hour later, we just know that it's an hour later. So now it's t plus 1. But we don't know what time it is. We just know it's an hour later than this. Okay. It's now 83.5. So you get another equation, 20.5 is equal to 35.6 e to the negative k t plus 1. Are you okay with those two equations?
Yes.
All right, now here's the cool manipulation that you can do to help yourself. You need to solve for k, don't you? So what we're going to do, and this is the cleanest way to do this, okay? Kind of like what we did with the other one, but not quite as complicated. I'm going to take this equation with negative kt in it, and I'm going to divide the whole equation by this other equation that I just got. So I'm going to divide the two equations by each other. Okay. And I'm going to use an ln to get rid of the e's. Okay. So ln 23.9 over 20 and a half. And the 35.6 is cancel. The e's cancel. Now what happens here, I've got negative kt and negative kt plus 1, right? Well, remember, I'm subtracting the exponents, so that leaves me with e to the k power. Okay, that leaves me with e to the k power when I do that. And you know how to solve for k from here, so I didn't do that part. And k is this, 0.153453578. Okay, now finally, and it's about damn time, we want to get t. This is the number of hours that she's looking at it after it dies. So you plug it in, you have 23.9, 35.6 e to the this thing times t. You know how to solve this. Divide by 35.6, take the natural log, okay, and then divide by this power. You'll end up with, and I didn't write the answer down, but it's in your homework. But the answer to this, you're gonna end up with k, I'm sorry, with t. You're gonna end up with t equals approximately, and I'm going to round it to the nearest hour. So t is approximately going to be a -3. Okay. Now what that means is that, remember, when did you find the body? You found the body at 8 o'clock in the evening, all right? What this means is that the body was killed at a -3 before this. So 3 hours before this time. If this had been a positive number, it would be after, but obviously it's not after that, it's before that. So it's 3 hours before 8 p.m. So when was the body killed? The body was killed at 5 p.m. So not particularly hard, but a lot of analysis
Yes, definitely
goes into that.
Well, I'm glad I have you, Shauna, because I couldn't done it without you, honestly.
This one was straight out of the book. The one that didn't have a good example was the concentration in the body. I had to go look for that example, but there's a problem that's straight out of the book that just has different numbers. So if you want to practice it, if you go to that example, there's another one you can practice with the book, and it's like straight out of the book pretty much.
Okay.
Okay. So that was, but you see why I wanted to make sure that I showed you those two, because
Yes.
I was like, especially number 6, because I'm like, I don't think, I mean, I worked on that thing for a minute before before
Yeah,
I
even yeah. If it took you a while, yes. Shauna, over the weekend, I don't know if tomorrow